Can you guys hear me? Just check. Am I standing in the right place? Hi, my name's Ken Farmer. I'm a data architect. I've been building analytical solutions for data scientists for about 25 years, since long before we were using that terminology. And according to Gartner, you guys spend about 50% of your time wrestling with data quality, trying to figure out the meaning of some piece of data, trying to figure out why it doesn't work the way you think it's supposed to work, trying to prove your solutions are correct, or diagnosing problems. That space is my number one challenge. It was 25 years ago, and in spite of all kinds of technical innovations that we've had in the industry over the last 25 years, it continues to be our number one challenge today. It is one of the top reasons why analytical projects get canceled. So IT has done a really bad job at estimating and understanding data quality for analytical projects. Most people in the IT space will bring to the table their experiences with transactional workflow-oriented systems where you're handling one piece of data at a time. But in our world, we handle lots of data at a time. And so data quality problems loom large, and they happen frequently. This is a typical kind of a scenario. I've been in front of customers being forced to say, yeah, here's your data. And when they say, well, what happened here? So, we have these unpleasant and awful conversations like, we don't know. Or we have a theory, or we could interpolate and fill that spot in, which doesn't make them feel very confident. It's like going to a used car salesman and having them say, that dent, we'll put some Bondo on that. So what ends up happening is that we find that in our space, the data quality problems emerge as one of the most challenging characteristics. I drew this up in LibreOffice. What I typically find is that most people adopt one of two different approaches to data quality. They either start out very, very hopeful, and I'd say kind of naive, and they take an ad hoc reactive approach to it. This is kind of, you could also call this approach the no money down, pay a lot later approach to data quality. The other approach is more methodical, less ad hoc. In this particular case, what we're looking at is we're anticipating that data quality problems will be the rule rather than the exception. Our success is largely going to be driven by how well we solve them. So a methodical approach involves three different kinds of activities potentially. You've got prevention, detection, and I swear that says resolution, when inevitably we really do have bad things happen. So most of the solutions that I see are usually prevention solutions, because it's easier to prevent than to fix bad data that's out in the field that people are using. There's quite a few of them, but I want to zoom in on just a couple of them. In general, the prevention space, we're trying to say, how do we reduce the frequency of these problems? And should they occur, how do we make it easier to detect them? And how do we make it easier to resolve these problems? Let's go ahead and look at a couple examples. So one example is QA. We're all kind of familiar with QA. Well, QA to a computer programmer might generally mean unit testing and functional testing. To a QA team, it might mean black box testing, maybe reconciliation reporting. To a data scientist, it means all the above, with an emphasis on the programming side. So let's talk a little bit about unit testing, because I think for those data scientists who aren't using unit testing, and I believe this is the majority, I think this can make your life wonderful. Okay, so the thing with unit testing, with automated unit testing, the programmer is going to tell you, well, he gets to validate the code, and maybe more importantly, it enables him to iterate very rapidly without having to pay the price of very expensive, slow manual testing. For a data scientist, there's three benefits that I see. One benefit of the automated unit tests are that you do get those faster iterations, because of course our work is very iterative here too. Okay? The second thing that you get is a reduction in cognitive load. So by reducing cognitive load, what I'm talking about is like the problem that I had drop in my lap on Friday. Very large, very complex, huge volume feeds, and one of the feeds in the security space is supposed to have an ID referring to the other one, and it's not always referring to it. Now, luckily, I've got enough automated unit testing that it allows me to discard the possibility of the bug or defect that I have to track down from being in most of my code base. My unit testing does that for me. I don't have to read through as many lines of code. I don't have to think about all that code base, because my unit testing has proven that most of it is working correctly. So that's the other big benefit for you folks in QA that I'd like you to think about. The second kind of approach in the prevention space is just pushing as much work upstream as you possibly can. So a lot of times we see a scenario where you have multiple data scientists working in parallel, producing results that are not in sync with one another. They cannot reproduce each other's results. The same data scientist will try to repeat something from 6 months earlier, and he can't even repeat his same results. And the reason why is because they're going back to some poorly documented large set of data, and they're having to apply their own interpretations to it. And the chances of getting 5 people to interpret some of these subtle data consistently is very, very small. So one of the first things we can do is we can try to push some of those transformations upstream, so that at this point, say prior to loading the data into Hadoop, we apply some of our common transformations, and now we can take all that work off the data scientist's table. Not only do they not get out of sync on it, but they don't even have to write the code for it anymore. So it's also good efficiency. The other thing that we can do is we can push it even farther upstream. This is this is quite broken. So what can happen then is, besides just pushing it up here, oftentimes you guys can get stuck in the world of minutia, of system implementation details from your source system. If you want to know how many customers your company had last month, you shouldn't have to know the details of 50 tables in an Oracle financial database, right? You really want that simplified, and that means that some of your transformations can be pushed all the way to the source. There should be some abstraction layer here, ideally maintained by the source. Maybe one of Tom's RESTful APIs could be a great way for them to hide some of the details there. Our detection solutions, we have quite a few. We don't have many detection solutions, so just want to look at one really quickly, and that's quality control. In this particular case, we're really trying to say, how can we detect the problem at the earliest possible opportunity? And a couple different ways that we start. Oftentimes you'll have a feed coming in. We have a lot of feeds. We have more feeds than most workflow systems. And a lot of these are feeds coming in from external systems, and we won't be notified when they make changes. It's just going to happen. And when this feed suddenly drops a substantial amount of its data due to business rule changes upstream, or perhaps our process ran out of disk and it was truncated, we don't want that to get into our data and pollute our results. So something trivial and simple can just be looking at, for any given feed, what's a record count every time you process it. You can have a hard-coded threshold, or maybe something more intelligent, a simple algorithm looking at what's the normal amount of data that you should get, and what's within 3 standard deviations or 2 standard deviations. So that's simple. The next level of sophistication is actually looking at business rules, specific filter rules, validation rules, transformation rules, looking at their output over time. It's not uncommon to have a problem in which you have a business rule that was filtering out 0.01% of your data, but it's grown over time, and it's now filtering out quite a lot of data. And then finally, we have many, many copies of our data, many replications. We aggregate the data, and nothing's checking to confirm that those are staying in sync. So some simple tools to measure counts and be able to see when they're out of sync is invaluable. Finally and quickly, resolution systems. And I'll talk just really briefly about 2 different kinds, tracking users and tracking defects. Both of these are invaluable once you get bigger. Tracking users is all about the question, okay, we screwed the data up, now who's got it, okay? And you can store copies of queries, and you can also store sometimes copies of the data. Ideally, you have both. When it comes to tracking defects, when we screw data up or we find out that there's data that's screwed up today, the reality is we're going to be still using this data in 9 months, but nobody's going to remember why it's screwed up. This, a very, very simple bug tracking-like system for tracking data defects is invaluable once we're mature, and it can easily be used as well to annotate existing charts of data. So we can identify when people have these have the tough questions here. Okay, last few seconds. And bottom line, data quality problems are one of the top causes of project failure. Managing them is expensive. Not managing them is even more expensive. A methodical approach works best, but keep in mind proportionality.